we've been looking at various components of report development in Power BI, from the extraction of data from various sources, transforming of data, modeling of data, which is the current where we are currently in. I'm hoping that we round that up today so that we get into DAX by tomorrow, and we'll be wrapping up the session in Power BI hopefully next week. All right, so let's quickly get to where we stopped in our last class. I've made a little adjustment to the data set we're working on. So I've shared the data set with us. So you can go ahead and download the data set, and that's the data set we'll be working on during the session tonight. So all right. So in the last class, we had moved from our application, unlike other times that we had to bring in data from different sources. At this particular time, we were generating our own data. So you can actually simulate your data. All right. So I will start from there where we simulated data. So I said for you to get that achieved, for you to get that done, so what you need to do is go to your ribbon and click on Enter Data. All right, when you click on Enter Data, right, you can, let me close this first. Let me go to the Excel that we're working with. So we can pick the Excel here. So we'll be working with retail data. All right, so we have customer table, sales table, and product table. So these are tables that have simulated. All right, so all we need to do is copy this. So you can copy this and bring it to your Power BI. Go to Enter Data. Let's get here. Click on Enter Data. So when you click on Enter Data, click on the column and drop it Ctrl V. All right. So when you click on that, you can label this as customer table. All right, and you load it to your model. Okay. So so we have customer table added. All right. So the next one I want to bring in is sales table. Right, you can copy the sales table and do SERM. Come to table view, home, enter data, click on column 1 and paste it, Ctrl V. Name the table as sales table. Load it into your Power BI model. All right. So the next one we'll be looking at is the product table. You can equally copy the product table. All right. Go back to your Power BI application, click on Enter Data, click on the column on column 1 and drop your data, paste your data. So this now becomes, you give it a label product table. And load it into your Power BI model. All right. So you can see now that we have 3 tables. We have the customer table, we have the product table, and we have the sales table. All right. So let's look at our table one by one. What are the fields that we have in customer table? So we have age, the age of the customer. So we have customer ID. All right. We have email, we have first name, we have last name, and we have phone number. All right. So let's get to product table. Within product table, we have, these are the list of fields we have. We have category, we have price, we have product ID, we have product name, and we have stock quantity. All right. Okay, so let's get to our sales table. Within our sales table, we have customer ID. All right, we have product ID, we have quantity, we have sales date, we have sales ID, and we have total amount. Okay. All right. So remember, like we said in our last class, that when you bring in multiple tables into your Power BI model, the first thing you will have to do is to create a relationship across the various tables using a common field that exists in each of these tables. Now, the essence of doing that is so that you can have accurate calculation, right? Or you can be able to perform analysis across the various tables that you've imported into your Power BI model. Because sometimes the business question that is thrown at you, the data you need to answer that question may not reside in one table. Sometimes it may reside in multiple tables. And for you to be able to bring those data into a single table, you must create a relationship across the relevant tables. All right. Okay. So that's where the concept of data modeling comes into play. Remember, like we said, that data modeling is basically establishing relationship across the various tables that you have imported into your Power BI model. All right. And we also talk about cardinality. So I said that cardinality has to do with the type of relationship that you've established between the various tables that you have imported into your Power BI model. Okay, so I'm going to talk about, I'm going to say something here. Our data sets are basically categorized under two types of table: fact table and dimension table. All right. So dimension table stores information that you will use to filter fact table when an aggregate function is carried out on a fact table. All right. So your dimension table is more like filters. They are seen as filters. While, the columns in your dimension table, they are seen as filters, while the column in your fact table are seen as measures. All right. So your fact table contains metrics that you can use to measure the performance of a system. All right. When an aggregate function is carried out on it. Okay. All right. So let's get back to our data model. Like I said earlier, that Power BI is smart enough to pick the relationship that exists between the tables. Most times the relationship may be wrong. That's why you have to look at it very well to be sure that the relationship that Power BI has established between the multiple tables are correct. All right, so let's look at the relationship. Okay, so this is customer and this is product. All right, we're going to explain the concept, this relationship, the concept behind this relationship. All right, so you can see that customer to product, the relationship is one to many. You can see that the relationship is one on the customer side and the relationship is many on the sales side. All right. We're taking time to talk about that. Now, the reason why the relationship is one on the customer side is because on the customer side, every record is unique. Now, the reason why the relationship is many on the sales side is because we have duplicate records. The records are not unique, all right? Why are the records not unique? For example, you can have a customer whose profile is captured in the customer table performing sales transaction, performing transaction multiple times in a single date or multiple dates, and those multiple transactions are recorded in the sales table against the customer. All right? Like we always say, a customer can buy multiple things from a shop. One customer can carry out multiple transactions in a shop. A customer can go to a shop and buy something in the morning, buy something in the afternoon, and buy something in the evening. It could be different products, could be the same product. So you can see now a single customer performs multiple transactions. So that is the relationship there. All right, let's get to product sales. So you can see we have a relationship of one to many. Now, this relationship is established based on the common field that exists between the sales table and the product table. And the common field there is product ID. All right. So you can have a single product that is captured in the product table. You can have multiple transactions on that single product in a given day. That's why you're seeing the one to many relationship. That means the records for product here, they are, but the records here can be multiple records. All right. Okay. So let me take this out so that we understand how this relationship is being created. All right. So if you look at this, you see that customer ID is here and customer ID is here. So the common field that exists between these two tables, so they bridge. What will bridge this table and this table is the customer ID. So this customer ID on the customer table is called a primary key, while the customer ID on the sales table is called a foreign key. All right. This is a primary key. This is a foreign key. A foreign key is a primary key on a dimension table. A foreign key in a fact table is a primary key in a dimension table. So like I said, that this is a primary key. All right. Primary key are unique. The values in a primary key are unique. All right. So a primary key here is a foreign key on the sales table. So that's what creates the bridge or the relationship between the customer table and the sales table. All right. So the same is applicable to product and sales table. We have product ID as a primary key on product table, and we have product ID as a foreign key on sales table. So we can drag product ID into the product ID from product table into sales table, and a relationship is established. So the relationship that established is based on the common field, which is product ID, and the type of relationship is one to many. All right, is one to many. One from the product side, and many on the sales side. All right. So the cross-filtering direction is a single direction. All right. So the filtering goes from the product to the sales table. All right. So we can click save here, and that relationship is activated. All right. So if you come to customer sales table, we have identified that the common key there is customer ID, which is the primary key on the customer table, customer ID, which is the foreign key on the sales table. So if you drag the customer, irrespective of the direction you want to use in dragging, it works. It's fine. So if you drag customer ID into customer ID here, a relationship is about to be established, and that relationship is one to many. one from the customer side and many on the sales side. That's what you're seeing here as cardinality. So the cardinality there is one to many. Remember I said that cardinality has to do with the type of relationship that exists between a given entity in your data model, the type of relationship. There are many types of relationship. You could have one-to-one relationship. You could have many-to-many relationship. You could have one-to-one relationship. But for the type of modeling that we are doing, which is a star modeling, all right, a star schema modeling, the most recommended type of relationship should be one to many. As much as possible, try to avoid one-to-one relationship, many-to-many relationship. All right. It is always advisable that you stick with one-to-many relationship. All right. So we click save and the relationship is established. All right. So let's quickly get back to our report view. All right, so when we get to our report view, all right, for example, let's say that we have, no, before we get to our report view, let's quickly get back to let's go back to there's some things I want us to do. Let's get back to our customer table and see how we can modify or transform this table. All right, let's see how we can transform this table. So I want us to merge first name and last name to become full name. All right, so how do we do that? We quickly go to transform data to load our tables into Power Query Editor, where we have the function that could help us achieve that purpose. All right, so what we need to do here is select. So we're going to select first name, select last name. I showed us the different ways of getting this done. So the first names and last name, and we are going to, what's the transformation we want to do? Merge the columns. So we are merging the columns using a separator. The separator we want to use now is a space separator, and we want to label this as full name. We want to label the new column as full name. All right, when you click OK, it merges your first name and your last name to become full name. All right, so you can come to format and capitalize each word. So you will have your first character being capitalized. Yes, this is a new file. Get to your WhatsApp and you'll see the file. So I said I made adjustments on the file. All right. So the next thing I want us to do is to create an interval, age range, to create a new column called age range. All right. Let's quickly look at the age that we have to create a new column called age range. All right. So let's get to let me quickly get to my Excel sheet. All right. Let me get to my Excel sheet.
Mr. Itwen.
Yes, please.
Did you say the full names that you've formatted them as the first letters of each of the names are uppercase?
Yes,
because I think some of them are already uppercase. So
well, even if some of them are already, there's no problem.
Okay.
All right. Okay, so let's get to I want us to create age range. All right. So let me pull out. Somebody just dropped this. Please, can somebody help resend that file? All right, equals to unique. Also, we have, oh, wow. Okay, so this is fine. So let's sort it in ascending. All right, so let's sort this in ascending. Let's sort this in ascending. Okay, so we have from 20 to, we have 24. The least age is 24. The maximum age is 45. Okay, so we can create a range 20 to 30, 31 to 40, 41 to 45. Are we good? Is everybody with me? Is everybody with me?
Yes, sir, we are here.
Okay, so
No,
I'm
here,
sure we
not
now we
everybody.
understand the range that I've created now. I'm creating this range based on the minimum age and the maximum age. So I look at the minimum age is 24, and I look at the maximum age to be 45. All right, so I wanted to, I'm creating an age range of 20 to 30, 31 to 40, and then I have 41 plus. So let me put it 41 plus.
Why can't you make it 50? I'm just
No,
curious.
we don't have
Okay.
such value. But this is 41 plus. To 41 plus kata for everything from 40 till infinity. Is that okay? Are we fine with the age range now? Hello, is there anybody that is having problem with that? No, there's nothing like 41 to 50. You are putting a cap. What if you now have data? What if you now have data that is we now have a record whose a customer whose age is a range? Who is saying no, 41 plus is not a range, it's a range. It's a range. So that's like anything 41 to whatever. If you have someone that is 60 years, it will fall under that bucket. So you have created 3 buckets. The first bucket is 20 to 30 years. The second bucket is 31 to 40 years. The last bucket is 41 plus. 41 plus means greater than or equals to 41. So everybody from 41 and above will fall under that bucket 41 plus. All right? It's 41 plus. You can say 41 and above, but I choose 41 plus. All right? We are still saying the same thing. 41 plus. All right? Okay. All right. So let's get back to our Power BI application. Right. Let me bring back my okay. All right. So we are going to create a new column called age range. All right. So how do we do that? We go to home, and the next thing we do, we go to add column. All right. When you say add column, so we want to create custom column or conditional column. So you can come to conditional column. All right. What's the name of the column? Age range. All right. All right. If column name, what's the name? If column, if age operator is greater than or equals to, value, 20. So we can manually type the value. 20. If H column operator is greater than or equals to 20, enter what? Is greater than, no, is, let me bring back that so I don't make mistake. Okay. So we had 20 to 25, right? Okay. So we now have sorry, was it 20 to 25 or 20 to 30?
21 to 30.
Okay, we had
21 to
20 to
40.
30.
it was 20 to 30, right?
20 to 30.
Then 31 to what? 40, right?
40.
Then we now have 40 plus.
Plus.
All right.
41 plus, 41 plus.
41 plus. Thank you. 41 plus. So we are saying if the H value is greater than or equals to, okay, if the H value is less than, if the H value is less than or equals to 30, all right, it's less than or equals to 30, then the output should be 20 to 30, right? Abby? Hello? Is that not what we put here?
Yes.
If H value is less than, this means that H value is less than, if the H value is less than 30, you understand? Is less than 30, is less than or equals to 30. This interval means that it's less than or equals to 30, right? Then 20 to 23, all right? So let's add another clause. If the H value is less than 40, if the H value is less than or equals to 40, I'm going to explain what you're seeing here. Sorry, less than or equals to 40, then what again? 31, Abby, to 40. Was it that? Okay. Else what? 41 plus. Is there anybody that doesn't understand? So I was expecting somebody to ask me a question. What's the difference between what's the difference between this? If it's less than or equals to, 40. Normally, this 30 is less than or equals to 40. Then all of this will fall under this. The reason is because you have already set this condition. Once you set this condition follows this sequence. Once you set this condition, the first condition is if it's less than or equals to 30, it should display this value. All right. So it has already filtered out all the H value that is less than 30. So the remaining one will be from 31 upward. So this next condition will now filter all the H value that is less than or equals to 40. So once it does that, it returns a value for any H value that is less than or equals to 40. It returns a value on a new column as 31 to 40. Then any value that is above 41, it returns a value 41 plus. So let's click OK and see what will happen. Did we see that? Did we see that? Hello, did we see that?
Yes, yes.
Yes.
So if you come here, you can see that what's the age range of this person? Is 34. You can see it falls under this age range of 31 to 34. This is 28, it falls here. 41 falls under 41. Can you see 45 falls under 41 plus? So let's put what's the highest age that somebody can have? Maybe possibly can we say well, let this be, remember what this is supposed to be 41 plus 41 plus. So
Yeah, the highest age when you look at it earlier was 45.
So let me come here, else 41 plus. Let me edit it on my Power Query. 41 plus. Let me see whether that should. It's not returning for me. Okay, I see why it's not returning. Okay. Oh, okay, let's put 41. Let's put 41. Let's say put 41. Let's just put an interval for the purpose of this class. Let's put an interval 41 to 50. All right. Let's put 41 to 50 for the purpose of the class. And why am I having this? Else 41 to 50. Boom, boom, boom.
He thought it's 41 minus 50.
Oh, it's 41 minus 50.
That's how he's treating it, isn't it?
It sees at 41 minus 50.
Like you don't quote it. It's supposed to be in parentheses.
Let me go and edit that condition. Let me go back and edit.
Which means that brother was right.
Yep. So that'll be 41 plus. 41 plus. Let's quote it and see what will happen. Let's see whether it can return that. Let's see. Okay, so it does. It's going to return it. Okay. Okay, so I think I know what I'm going to do now. So we can just say 41 plus. Okay, let me see whether it will return. Yep, so that's it. Thank you. You know why? Because in anything in Excel, you do the same thing. Without that, it's going to it's going to return it as 41. All right. Is it clear about what are you guys clear with what I did?
No, we are
We're
not
just
clear.
looking at you. We're
We're
not
not clear.
And nobody said anything. All right, so let's go back again. You know, if you want to edit your condition, you come here. The apply set, you click here. So we click here. So what I did was 41 plus, all right? So that 41 plus will stay. If you put 41 only, it won't stay. So what you do, even in Excel, what you do is you put single quotes. Are you with me? Then you now say 41 plus. So that will stay. So if you click, okay, now it's going to stay. You see 41 plus. If you don't do it that way, it won't stay. You only see 41. Are we together? Hello, are we together?
Yeah, Mr. Ituel, I think putting the single column comma makes the value an object and rather than number. So that is why it's displaying the 41 plus. That 41 plus, the Power BI is seeing it as an object.
That's how it's supposed to be. It's not
Yeah.
this thing. You're not going to perform any aggregate function on this now. So it's more
Yes.
like a text. If you look at it, that column is going to be a text column. Can you see that it's a text? Can you see?
Yeah, it's a test. Yes,
More
exactly.
like alphanumeric. Yeah.
Yes.
All right. Okay. All right. So I can close and apply, right? Can I close and apply? Is there anybody that wants to ask question? Hello? Is it clear? Is it clear?
Yeah, it's clear.
Okay, so let me close and apply. So I'm still going to come to do transformation in another thing. All right. So so I'll close this. So if we get to my this thing now to our Power BI, you can see that we have a new column called H range. All right. Full name. This one jumped to this side. I didn't want to bring it, well, irrespective of the arrangement, it doesn't affect your analysis in any way. Okay. However, the thing wants to, but you can always go to Power Query Editor to rearrange it, rearrange your columns or your field. All right. Okay. So let's get to our cells. Let's do our sales table a little favor. All right. Our sales table. Okay. So sales table. Can we classify our sales as high volume, low volume, average, no. What are the quantities? Okay, quantity. Can we classify the quantity as high volume, low volume, and average volume? Okay, high volume and low volume. Can we classify that? Hello, can we classify that?
Yes, let's do that.
Is this something we can do? Look at the quantity. You look at the quantity. First, what's the highest quantity? The least quantity is 1, the highest is 6. All right. So you can classify it as low volume or high volume and put the and give it a anything. What do you call it?
Your range?
You give it the column a name. All right. Can we try that? Is this something we can try? Can we try that? Can we all try that? Hello, can we try it?
Please call me again, sir.
I want us to, excuse me, please. Look at the quantity of our cells. All right. I want us to classify our cells under low volume or high volume cells. So I give the column name is cells volume. Whether it's going to a low volume or a high volume. All right.
Yeah,
Can we try that? It's very simple.
Yeah, we can.
Okay. So you create the range for low volume, you create the range for high volume. Right? Create the range for low volume and create the range for high volume.
Well, was this range thing, was it taught on Saturday?
It wasn't part of Saturday.
It's what he just taught us now.
Oh.
Have we gotten that? I want to quickly get to DAX measures and DAX column. So that tomorrow we can see how we can start visualization. Has anybody done it? Has anybody done it?
That's okay.
Sorry, Mr. Itwe, I lost you there. My internet is playing up, so I'll just be in listening mode. I've missed out on
So I
what
want
you were
us to
saying.
create a new column called sales volume. create a new column called sales volume. And the values that you should have is within that sales volume should be low volume, high volume. So we are going to use the quantity column to create a new column called sales volume. Then the value should be either low volume or high volume. Given the range of our cell, of our quantity, you have the least to be 1, the highest to be 6. So create a range within this sales quantity and label 2, create 2 intervals. Label 1 as low volume, label 1 as high volume. All right? You can say anything less than 3 is low volume. Anything, you can say less than 3. Anything less than 3 is low volume. Anything above 3 is high volume. Or anything, so anything less than 4 is low volume. Anything above 5 is high volume.
So where will fork fall in?
It's gonna, listen, anything less than 4 is low
Low
volume.
volume. Anything above 5.
Anything less than 4. Sorry, anything less than 4
Low
is
volume.
low volume. Anything
Anything above 4.
Anything greater than or equals to 4 is high volume. Is anyone that is done, please indicate so that we can look at it and we proceed.
I finished.
Awesome. Share your screen if you are finished.
Can you
For me,
see?
I'm seeing under your age, under your this thing, age range, I'm seeing some values are blank.
This is what I'm showing.
Okay. So we have low volume and we have high volume. Your screen is small. Awesome. So we have low volume and we have high volume. So go and click on that. Go to your apply steps. Go to your apply steps. Apply steps. Go to the applied steps. Applied steps. Please, can somebody guide her to applied steps?
To your right.
Steps,
to your right.
Your right. That documents all the steps that you've carried out.
Oh, okay.
Go to where you do added conditional column. Click on the asterisk. Sorry, click on, click there. All right, so be able to see the condition you defined. So we can see now if it's less than 4, low volume, all right? Else, high volume. Awesome. This is awesome. Very simple. Can you see? It's awesome. You didn't even use our description. They just use, if it's less than 4, low volume, else, high volume. That's awesome. All right. So that's how you can use condition to create a new. You can use condition to create a new column from an existing column. All right. Are we together?
Yep.
So that's how you use condition to create a new column from an existing column. All right. Okay. All right. So let's quickly. Somebody wanted to say something. All right, let's quickly get back to our report view. Okay, so I'm going to talk about 2 things. I'm going to talk about DAX. All right, DAX meaning data analytics expression. All right. it used to carry out calculations within Power Query in a Power Query model. All right, it's used to carry out calculations in a Power BI. All right, so it can basically be used to create a table. It can be used to create calculated columns. It can be used to create calculated measures. So we have used DAX expression to create a table. That was calendar table. All right. Do we still remember that? Hello, do we still remember that? Do we still remember that? Somebody should talk to me now. Do we still remember that?
Yes.
Where
Yes,
we
sir.
say calendar equals auto what? Auto calendar. All right. So let's implement that. So let's create a calendar table. Let's go to our data set and create a calendar table. All right. So how do we do that? We go to our home and we click on what? Where do we click? Somebody should tell me now, should tell us. Can somebody remember? Where do we click? Let's get to our table view. Where do we click? Go to your home. Where do we click?
Model view.
Where?
Model view.
No.
Nope. We want to create a table using DAX. Where do we create? Where do we
New,
click?
new table.
Awesome. We click on new table. When you click on new table, this bar opens up where you write your DAX. Remember that the DAX you want to, the table you want to create is called calendar table. Calendar table should be equals to what? Auto calendar. All right. Remember I said that what this does is it will go through your data set. It will check for your minimum date and your maximum date, and it will generate consistent value, date value from your minimum date to the maximum date without any broken number. Now, if your minimum date was 1st of January and your maximum date of transaction was 31st of January, it will go and pick your minimum date and your maximum date, and it will generate date from 1st, 2nd, 3rd, 4th, 5th till 31st. Are we together? Hello, are we together? Somebody should talk to me now. Are we together?
Yes.
Yes.
I need to be sure that we understand, please. All right.
Mr.
So
H1
when
is
you-
not auto calendar, is it calendar auto?
I didn't get that.
You said auto calendar, but
Don't mind
you
me.
wrote
The same
auto
thing.
calendar auto.
Don't mind my village thing. It's calendar auto.
Okay.
But it's the same thing now. Auto, just that I decided to turn it the other way. Thank you,
What wasn't coming up?
So it's calendar auto. All right. Is that okay?
Yeah, sure.
Am I forgiven?
Thy sins are forgiven.
Thank you. I shall sin no more. All right. So when you click enter, can you see it auto generates? Can you see it generates consistent date? Can we all see that? Hello, can we all see that it generates consistent date? Are we together? And it returns a table called what? Calendar. So all we need to do is go back to our data model. When we go back to our data model, we can now create a relationship. That's if the relationship, now the relationship didn't exist. All right, so we can bring our calendar date here. All right. You can bring our calendar date here. If there's anything that you should be interested in, it should be modeling. You're going to do some crazy modeling tomorrow when we want to start visualization. All right. So all you need to do is to come to sales date, drag this date into cells date, it's going to be 1 to many. All right, 1 on the calendar side, many on the sales side. Why do we have 1 on the calendar side and many on the sales side? Can somebody attempt to explain that? Can somebody attempt to explain that?
It is taking
Yes, like
each particular day.
somebody may buy many things on a particular day.
Awesome. Awesome. That's awesome. Awesome. All right. So the other person wanted to say something, please. Could you also add your own view?
I said it is taking the transactions for each particular day.
Awesome. All right. So if you click save, the relationship is established. The relationship becomes a 1 to many. All right. Becomes a 1 to many. I don't like it this way. Let me take it this way. I like it like this. Is it not fine that way? All right, so let's get back to, okay. So let me bring back my, okay. So remember we said that, it has disappeared. Where are you now? Come back. Okay, so remember we said that DAX is called data analytic expression. That DAX can be used to create a table. Example is a calendar table. DAX can be used to create a column called calculated column. DAX can be used to create a column. All right, and DAX can be used to create a measure. All right, so I said that a column, a calculated column and a calculated measure, they are different. Now the difference between a calculated column and a calculated measure is that calculated column stores, it returns the value and store it in our data set or in our data model. It stores the result of that calculation in our data model. Whereas a calculated measure does not store the result of that calculation or expression. All right. So the result of this expression is stored in the data model. All right. Now the result of this expression is not stored in a data model. Are we together? Please, everybody should give me attention. I'm going to say some sensitive things here. These are interview questions for anybody that wants to venture into for a Tableau developer job. These are one of the questions. These are one of the key questions. All right. Difference between calculated column and calculated measure. All right. All right. Stay with me. So the next thing is, I wanted to say something. Now, calculated column calculated column is mostly used with dimension tables. All right. I said two things. Who is sending me a love letter? I'm getting the error message, creating the calendar table. Why are you getting an error message? Is there any other person that got an error message? Is there anybody that got it right? I'm
Yes, I
surprised.
got it right.
So if one person got it right, so I'm happy. All right, so the people that got error message, can one of you share your screen? One of you should share your screen. Let's look at it together. Can one of you share your screen, please? All right. So go and click on, go to home. All right. First, go to table view. Click on home. Home. Now click on new table. New table. All right. So type the calendar. Equals to close the this now, the parentheses, enter. So why did you have error? Because this is what's the error there? Please read it for me. Data type, wrong data type. All right. Go back to your sales table. Go back to your sales table. Just click on your sales table. Click on your sales table now. Let it populate. Go to the list of go to data and click on your sales table. Who is this? Please go to your data and click on the sales table. Yes, now that's what I said. Sales table. So where is the date on your sales table? Your date was not properly formatted. Click on that date column. Click on it. Now go and convert that date to date. Go to data type. No, go to data type. You can see data type up there now. Down. Go to, you see data type now. Please, can somebody guide him on? See data type there. Data type whole number. Go and change that whole number.
Your left.
Change it to date. Now go back to your formula. Go back to your this now. Go back again to your calendar. Go to your calendar. Go back to that calendar table there. No, on your data pane. Go back to your data pane. Go to your data pane, the list, and click on calendar. Can you see that it has entered? Now click refresh error to disappear. Are we together?
Yeah.
Hello, are we together?
Yes.
I'm sure others have seen that. What was responsible for that? Solomon Coker. When is the naming ceremony? Don't mind me. All right. You said?
I said you are telling the class already. Thank you.
Okay. All right. So, okay. That's that. I'm sure others have corrected the error. Please.
We are in listening mode. Look
No.
at it.
While you're in listening mode, please also, if you except you want to go back to go through the video, but if you see an issue like that, Please try to check whether
Okay.
you're not you're
For
not
so
also,
long, I'm having problem with my internet, so I keep dropping out. So.
okay, no problem. All right, sorry about that. All right, so let's get back. Let's get back on track. I was a little distracted. All right. Please, you can go ahead and drop any queries you have. I'll pick it up. All right, so I said that calculated columns, have you calculated column or columns, is mostly used with dimension tables, while measures or calculated measure is used with fact table. All right, it's used with fact table. Yeah, go ahead, please. I'll run the script again. Give me a little time. I'll run the script. All right. Sorry about that. Okay. So you can see that calculated measure is used with fact table. All right. Calculated measure. So the result of this expression is not stored in a data model and is mostly used with fact table. All right, let's see how we can implement this. Okay, let's return back to our table. Okay, excuse me, let's go back to our customer table. All right. You know, we could have written this using we could have written this using this is an example of a calculated column. Are we together? Are we together? Are we together? Hello, are we together?
Yes, Mr. Ita.
You know, we could have written this using calculated column. We could have done this using calculated column. This is an example of a calculated column. DAX calculated column, right? So we could have come here, let's say we could have said here, new column, all right? I could have said, new, let me say new age range equals to if age is greater than or equals to 30 equals to, what was that thing again that we brought up? It's not audible. Somebody is saying, In fact, let me not use this one so that I won't make somebody to start. I'm already hearing a sigh. All right. I'm going to go and use a calculated column somewhere else. All right, so let's go to sales table. All right, are we together? Are we all together? Are we all together?
Yes, yes.
All right, so let's add a new column. Let's add a new column called average sales amount. All right, a new column called what? Average sales amount. All right, average sales amount. What will be average sales amount? Average sales amount will be average of what? Average of what? Average of total sales amount. Right? Is it not so? Is it not so? Hello, is it not so?
Yes.
Average sales amount equals to average. Some of you have done Excel now. These are basic Excel. All right. Like I said, that calculated functions are more like performing calculations within your Excel. So it carry out the expression for each record, row by row. So we are heading to that. That will be my next next item on the difference between calculated measure and calculated columns. So calculated measure is row based. All right. So when you click this, it returns your average. Are we together? Hello, are we together?
Yes.
So if you are saying average, what average? We want to know the average of what? Average of the total sales. So it returns the average for each record, average for each record, average for each record. So what it does is it sums out, it sums all the values on the total amount and divide by the count number of records. All right. So that gives you the average sales amount. Okay. That's using calculated. Remember, that is using calculated what? Column. You're using calculated column to perform this. All right, so let's also use calculated measure to perform this. We use calculated measure. You come here and click on new measure. So calculated measure will be, let's say, average sales amount. Average sales amount will be equal to what? Sum. Are we together? Sum of what? Total sales amount. Are we together? Is everybody with me? So when you click enter, it returns what? Did it store on this thing? It didn't store. Did you notice that it did not store the result? The result of this expression was not stored in your this thing, in your data model. Have you observed that? Hello, have you observed that? Everybody's quiet. Somebody should talk.
Yes.
Yes, we observed it.
So when we did look at calculated, can you see the calculated columns? When we did calculated columns, the result of it is stored here. But if you click on calculated measure, the result of it is not stored anywhere. The only thing you see is the expression. So the difference between calculated column and calculated measure is that calculated measure is stored, the result of that expression, calculated column expression, is stored in your data model. But the result of calculated measure expression is not stored. It's only the expression that you will see. All right? But these two will give you the same output. Now let's go to our report view. When you get to your report view, drag this average cell, drag it here. So let's bring out a card and click on average cell. What do you have? 28.05 thousand, right? Are we together? Somebody should talk to me now.
Yes, we are together.
Now come and bring another card visualization and click on. Is it not the same thing? It's the same thing, right?
Yeah.
Yes.
It's not the same. One is saying 28.0.
0.5 is not there now.
And the other one is saying 28.
What's the
Exact.
difference? What's the difference?
0.05.
One is
What's the
close.
difference between
If
the
you round
One
it
is
up, say
close.
20.1.
You can.
One still has decimal, some decimal point. The other is a whole number.
28.1 is the same thing as 28.
Some accountants will disagree with you on that.
Accountant will disagree with me on that.
Average.
They're dealing with average. Do you understand? We're dealing with average. All right? Are we together? So there's no difference. There's no difference between. I can decide to wrap this. This is already compressed. I can decide to compress this. All right? I can decide to come here and compress this.
But how come they have 1/2 point and the other one doesn't have? Is it not the same formula that was used?
No, this one by default, it rounds it up to whole number.
Okay, you approximated it. Okay.
Yeah, so I can decide to come. Personally, I don't like keeping values like this. I can round it up. All right. I can decide to round this up. We are dealing with average. So I can decide to come here, come to is it data format? Where's my data format? I'm already entering into data visualization. So I can, okay, it's already text, it's wrapped. Okay, auto. I can decide to none. No, none that gives me more. Can decide to make it was in 1,000. Where is that place that I can wrap up my this thing? Sorry. Let me not waste my time there, but I can wrap it up. So you can wrap it up to 28, all right? Okay, so what I'm trying to show you guys is that you can see that this and this are the same, right? In terms of the output. The output is the same, it returns the same result, but the expression, when you're writing the DAX expression, one stores the values in the data model, one does not store the data, the output in the data model. So it is always advised that you go for DAX measure instead of calculated columns when you're performing this kind of expression. All right? Why do we do that? Because every DAX calculated column that you perform, it will increase the volume of your data set. Imagine that this data set, the records here were up to, let's say, 10 billion records, and you add another column and you store additional value. You know what that means? It's going to impact on the performance of your report. It will slow your report. All right? It's going to slow down your report. So it is always advisable to go for DAX measure instead of DAX calculated columns. All right? Because DAX calculated columns that expression does not return values to your data model. It doesn't add value to your data model. The value of a DAX measure expression is only seen at the time of your visualization. When you're using that expression in your visualization, that's when it returns an output. All right? Are we clear with that?
I have a question, please.
Okay, go ahead.
On this average sales amount column, I'm confused. Average sales because every sale date, I mean, we have different dates on that sale dates. So should it be the same thing all through? I don't know.
When you're looking at average, you're saying average. What is the average sales across the window period of time you're considering? Do you understand? We are not looking at it on a daily level. We are looking at it across the entire period. What's the average sales? All right? Are you with me? We are not looking at it on a daily level. We are looking at it, the average sales across the duration in which this sales transaction was carried out. I think this sales transaction was carried out within a month, right? Because I'm seeing July. Yeah, it's July. It's July that within the month of July, what was the average sale for every day within the month of July? So it gives you an average sale that an average sale was 1,402. That was the average sale. So in terms of analysis, any day that your sale was below 1,402, that means you did not do well. You fall below average. All right. Any day that your sales was above that, that means you did well. The sales for that day was actually okay because you're looking at the average sales within a month. You can also look at average sales within a day. All right. Are we together? Hello, are we together?
I'm with you. I'm not 100% convinced. Yeah.
You're not convinced?
Yeah.
Are you
I don't
serious?
know. Just yeah.
Please.
Because so are we saying is the target sales now?
What do you mean by the word average?
To me, is probably this the summation of total amounts divided by maybe the sales under products. I mean the sum
word
of this.
average. So what average is total
Yeah.
sum of your entire sales divided by the total transaction that result in those sales.
Yeah, I agree.
I think the confusion there is because the average sales, is recorded against each transaction there.
Yes. So when
that
it's
is-
recorded against each transaction, you didn't get what I said. So when you're doing average sales, all right, this is how it is captured. When you're doing average sales, the average that we are carrying out here, what was the window period for this calculation of average? It was within a month, right? Are you with me? It was
Yes.
within a month. Now these sales are captured within a month, and you want to know the average sales within a month. So the average sales within a month will now be the total sales divided by the total transaction within that period of time. So you can see that while we are keeping, so the average sales column here has to do with the average sales within this time period that we are considering. So you can see that the average sale for January is this. The average sale for this is this. It's the same. Average sale does not change. All right. It's the same within the window period of time you're considering. It's going to be the same. It
Yeah, I
doesn't
agree.
change.
I agree with you. However, if you are going by the definition you just mentioned, the total sum. So what are we using to divide? Is it the distinct count?
of the sales.
Is it count of the product ID or what?
The count of the records. What's the total number of records here? We have 20.
Okay.
The records here are 20. So we sum the whole of this and divide it by 20 to give us the average.
Okay.
Do you understand now?
Yeah, I'm getting you.
Please, if you are not clear, ask question, please. We are going to talk about average as we proceed in our analysis. We'll talk about average. At some point, I will ask you guys, if you want to perform analysis, for example, you want to track the performance of a cell in a particular region, which would you go for? Is it total sales or average sales?
It's average sales. Yeah, it's always average
It's average
sales.
sales because it's average sales that reveals the true performance of your product. Do you understand what I'm saying? You can't use total sales. For example, I like using this example. For example, let's say you have products, you have iPhone and you have Android phones. There are some Android phones that are 100,000. An average iPhone should be 1 million plus, right? And you have 10 iPhones that were bought in a particular location. Those 10 iPhones that were bought in a particular location is like let's say those 10 iPhones were like, let's say average, let's say, okay, 10 million. And you have 50 Android phones that were bought in that same location. Maybe each of them is 500,000. Would you rather say that the iPhone is, would you rather say that the iPhone is doing well compared to the Android phone? Because when you sum up the revenue, you will discover that, no, let's say 200,000 for the Android phone. When you sum up the revenue, you will see that 10 pieces of that iPhone accounts for a higher value of sales than, let's say, 50 pieces of Android phone that is about 50,000. So would you rather say that iPhone is doing better than Android phone? Hello, are you with me?
Yes, I'm with you.
Would you rather say that iPhone is doing better than Android phone?
No.
You won't. Because when we get into sales, sales is not about value. Most times sales is about volume. It is volume that you use to check whether your product is doing well, not value. Because the person that comes, the people that, how many people buys iPhone at a time? It could be that maybe something, an event happened around that environment, or some crazy guys find themselves around that environment and they decide to pick 10 pieces of iPhone. And that kind of transaction, that volume of transaction may never happen again in the next 30, 40, in the next 12 or 6 months. So if you now look at that and you now decide to go and stock that location with, let's say, 100 iPhones, you'll be so shocked that it will be there and nothing will happen. So we don't look at value, we look at volume. So now if you want to check the performance of a product, what we're looking at the average sales. We don't look at the total sales. So we want to divide the total sales by the total transaction. That gives you the true position of the performance of a product. When we go further, we'll talk about this. I know it's a little bit confusing. It's still confusing. All right. Is there any other question or we should proceed?
I'm sorry to drag this, please.
No. It's part of it.
I tried to check it manually. I find out that it's not the same. If you go by sales, because I think you mentioned sales ID, or are we using sales ID or product ID? Because if I go by sales ID, I won't get this amount. But
let's get back to the calculation.
All right.
Average sales. What was average sales? What's the total sales here? What's the total sales here? If you want to calculate the total sales here, let's go back. Let's go to the total sales. Let's use a measure to calculate total sales. I like the class when it's like this. All right. So let's say total sales amount. Right. We're using measure to calculate this. Total sales amount will be total. It will be sum of what? Sum of all right. So since it is a measure, it won't be stored in the listing. So let's get to let's find total amount. What do you have there?
28 here.
28K. Let's go back. I brought in the wrong listing. Should be more than that. Let's go back. Oh, should be more than that. Sum of both 28K. Why should average also be 28K? Why should average be 28K? That's 28,000, right?
Because the total amount is, if you sum it together, it will give you 28,050.
Yeah, exactly. It's correct. So average is that. Why should average give you the same thing, right? Okay. So hold on. Stay with me. Stay with me. You're going back there. That's correct. So let's look at the total transaction. Are you with me? Are we together?
Yes, sir.
So let's get back to calculated. Let's go back again to calculated, measure, and perform total transaction. Total transaction is going to be row counts. So it'll be total transaction. equals to row count. Count rows. Count rows of what? Of which table? Count rows of which table? Count rows of cells table. All right. So all right. So let's get back to our visual. So let's bring this. So total transaction. What do we have? 20, right? Right?
That's
Are we
correct, sir.
together?
Yes, yes.
So divide it by 20. What do you have?
133.57.
133.57.
Oh, sorry. Are you dividing by 20 by directly?
Divide 28K by 20. Yeah.
Oh,
What do
okay,
you have?
okay. We are 1402.5.
1402.5. Right. So let's go back to our
Table.
average sales. So we made a mistake on our average sales. So our average sales would have been, this would have been average. Can you see that?
Yeah.
Thank you for that. 1403. So you made a
Okay.
mistake in our addition. Are we together?
Yes, sir.
We're together. So let's get back to our average sales. Average sales was okay. So this was our average sales. So when we brought this, can you see that? When we brought this, there was a problem. He said sum of average sales. So it shouldn't have been sum of average sales. It should have been average sales. Thank you for drawing my attention to that. Hello? Are we together?
Yes, sir.
Yeah.
Is this still confusing? So this is the average sales. It's 140 this is, but when we got here, and I'll see what he was trying to say. So it's 1403. Is it clear now? Hello, is it clear?
Yes, sir. Yes, sir.
So this was the problem was I made a mistake in our calculation. So you can see the total transaction, total sales amount, and total transaction. So if you divide this by this, it will give you this.
Yeah,
Are you
you know
with-
why I asked this question? Because I was not in the class on Saturday, but I watched the video, and you got to a place where you were doing self data, trying to input some personal data. So I tried to dabble on it, and then I saw different formulas, so which is quite different from this. But when I did it, I was able to get different average sales.
You got different average sales?
Yeah, for
You
every
can't get you can't
So,
have different you can't have different average sales for every record. It's not possible. That's an error.
all right.
Average sale is a common denominator across every cell that you're considering. When you say the word average sale, that word average is used for analysis. Do you understand? So for example, let's get back here. We have calculated the average sale for the month of July. So what do you want to use average? What do you use average sales for? You use it as a benchmark. All right. So we have displayed average sale now. If you look at this analysis, you can see that your performance on 1st of July was below average. Are you with me?
With you.
The performance here was below average. At what point did you have above average? It was on the 4th. You can see that you have above average. Do you understand?
Yeah.
I can bring in another measure. I can bring in another column here and say, I can bring in another column here called remarks. All right.
Okay.
I can tell you
Okay.
if the value of the total amount is less than average, return below average. If it's above average, return above average.
Okay.
Do you understand? So what you
Yeah.
use average for is you're using it to check the performance of your cells. So average within a given time frame is the same. All right, it's the same. When you're saying average, average has to do with you're summing the entire sales for that period, and you divide it by the transaction within that period, the total transaction within that same period. So it will give you the average. All right, that's why you hear somebody says your performance is below average. For example, let's say let's use a class. Let's use a class, for example, and you're looking at students' core performance. All right. If you say that a student's score is below average, your student score is below average, that means you've compute the total score of all the students in that class and divide it by the count number of students. So you can now say, oh, this particular student, your performance is below average. All right? Do you understand what I'm trying to say?
100%. I get your point there.
Yeah. So average is a unique value. It's a unique value across all the observations that you are considering, because you have factored in all the transaction into your computation. The first thing you do is you sum up the total score and you divide it by the total number of students in that class. So you can now say, oh, this particular student, his performance is below average. This one, he's above average. It's a way of, is used to measure performance within a given time frame or within a given environment. So that's what average is used for. All right. It's used to check the performance of each observation. Is this particular observation within below average or is above average? Okay. Well, if we have time, we'll talk about that when we are considering business requirements. I'm sure others are also learning something from this.
Yes. Yes, sorry, please, I have a question, please.
Please go ahead.
I think this header that we have, sales, customer ID, product ID, quantity ID, the place that we have total amount, and we have in now average sales amount, there is no sales table that's giving us a value in which we use the value to get our average sales amount. So
it has given you value now. It has given you value. You could have done that. It has. Look at this. I could have. Look at this. When you use the word average, average is a function. Do you understand?
Yes.
It's a function. Within that function are scripts that does that for you. It's a function that already does that for you. It has taken the burden from you. Average is the same thing as mean. I hope you know that there's no difference between average and mean value.
Yes, I know. My question is this. Are we labeling the header correctly? Is it not what is getting us confused? Because
no, it's average sales. No. It's properly labeled. Average sales. Average sales amount is correct. Yeah, it's properly labeled. Because you are looking at the average sales within that month of January, within that month of
July.
Yeah. When you get into real analysis, and sometimes you will see somebody ask you, please, can I have the average sales for last month? Can I have the average sales for this month? Can I have the average sales for this week? Why is that person asking you that question? He's asking you that question because he wants to check the performance of sales. All right. He wants to check the performance. He does, okay, what was the average sales amount for last year?
Last month. Yeah.
They won't ask you what was the total sales. No, total sales, it can be a little deceiving. We'll just ask you, what was the average sales for last year? The person will look at it and use that for comparison. All right. Okay.
Yeah. Thank you. Yeah.
Okay. All right. Thank you for that. Thank you for that. He's that person. I didn't even look at the person that asked me that question. Who is the person that brought this conversation?
I think it's Adebola.
Adebola.
Sir.
Adebola, that's cool. That's cool. Well done. Okay. All right. So, while trying to answer those questions, have you discovered that I've created additional measures? Did people observe that I created additional measures? I created total
Total sales, yeah.
total sales, and I created total transaction.
Okay.
Look at total transaction. What are total transactions? Total transaction has to do with the total records within a table. Remember that each record is a transaction. Are we together?
Yeah.
Each record is a transaction. So if you want to know the total transaction, all you need to do is count rows. You're counting the rows within the table. So total transaction is count rows. All right. Now I want to also say something here. Let me say something here. That's I'm having a lot of stuff. Okay. Now DAX measure is used to perform aggregate functions. Right? DAX measure is used to perform what? To perform aggregate function on facts or numeric columns. Right? Whenever you have to perform, whenever there is need for you to perform aggregate function on numeric columns, please, you're advised to use DAX measure. You're advised to use DAX measure whenever you're performing aggregate function on numeric columns. You are advised to use DAX measure. All right. So you can see that example of an aggregate function is minimum, maximum, and what again? Minimum, maximum, and what again? Count, average, sum. All right. For example, if you want to see our minimum sales amount, all right, what was the least amount of sales? Can somebody create that for us using measure? What was the least amount of sales? Least amount of sales, and I want to see the least amount of sales and the highest amount of sales. Can we try that? The highest amount of sales, these are the things I want us to do. The highest amount of sales using DAX measure calculate the following. Minimum sales. Okay, lowest sale value. Lowest sales value. Highest sales value. And what again? Highest sales volume. And let me also clarify something here. When you're talking about value, value has to do with the amount, volume has to do with quantity. All right. When in the context of sales, volume has to do with quantity, value has to do with amounts. Can we try that using DAX? Can we try that? Hello, is this something we can try? Hello?
Yes, it is.
Okay, please, let's try that. It's very simple. Are we done? Are we done? Are we done? Are we done? Has anybody finished?
Not yet.
Nobody has finished. This is serious. That's the simplest thing you can do. Nobody has finished.
Yeah, finished.
Has anybody finished?
Yeah.
Please share your screen if you have finished. Share your screen if you have finished, please. So that's the lowest cell. Is the highest cell. Okay. What's the highest volume cells volume? Want to see highest cells volume? Highest cells volume, that's highest cell, lowest cell. What about cells volume? Highest cells volume.
Highest and lowest.
What's the high? What of highest cell volume? There was one person that did that. Okay, please stop sharing. Stop sharing. Could you please stop sharing?
Okay.
Okay.
Yeah.
Okay. All right. So get to you can click here. All right, so we can go to new measure. What do we want to create? We want to calculate lowest cell. Was it lowest cell? Lowest cell value. Cells value. All right. So lowest cell value is supposed to be minimum. All right. There's a function called minimum. Minimum of what? You go to cells. Minimum of what? Minimum, use this in single quote. It will reference all the tables. You're looking at minimum of what? Minimum of total amounts. You close the bracket and you click enter. All right. So if you click on this thing here, I bring a card here. Let me drop another card here. Today is not this thing. So you click here on lowest cell. You will see that the lowest cell value is 250. All right. So let's try create another one, another new measure. All right. Highest cells value. Highest cell value will be what? Max. All right. Maximum of what? Maximum of cells amount. All right. If you click that, You can bring a card here, and you now bring in highest. This is, what was that? It was 4,500. All right. Okay. So let's see the highest sales volume. So let's go back to our new measure. And what's the name of the measure this time around? Highest sales volume. So the highest sales volume will be what? Max. Max of what?
Volume.
Not volume. Max of
Quantity.
Quantity, yeah.
All right. Not in product. Sorry, it's in product table rather. I think it's in product table. No, let's go to sales table. Sales quantity. We are looking at sales, not stock quantity. Are we together? So sales this thing. So you close the bracket and you click enter. So you can come here to cart and bring this again. And you can do here highest sales volume. Maybe? All right. Are we all together? Can we all see that?
Yes.
Is it clear?
It's clear.
All right. So let me show us a little something. Let me show us how beautiful this could be. You can check this. Well, you can check your average. You can check, sorry, you can check your total sales. You can drill your total sales amount. Do we have products there? Do we have? The data set is too small. It won't really make sense. It won't really make sense. It's small. Let's just stick there. Okay, let's quickly get back to our table view. Let me see if I can bring in something else. Let me see if we can bring in something else. All right. So we can check our total sales by range. All right. Our total sales by range. We want to see which range of our customers had the highest amount of sales. All right. So we can bring this. You can bring a stack bar chart. I'm going to talk about this tomorrow. So we can now bring in our sales, total sales amount. We can bring in our total sales amount to x-axis, and we can now bring in our age range. Our age range is supposed to, hold on, so I don't confuse us. Let me bring in a table first. A table. Let's bring in a table. Let's bring in our age range. Then we can now bring in our total sales amount. So you can see the total sales amount by age range. Are we together? I'm not doing visualization today. It's tomorrow that I will start visualization.
But you are doing it.
I'm just showing us something. You're saying, but you're doing it. So you can change this to a bar charts. All right. So if you change it to this, you can see that. All right. You can see that I didn't want to do this thing today. All right. So you can see that the highest, you can see that it was people within the age range of 31 to 34 that accounts for the highest number of sales in terms of value. Are you with me? Hello, are you guys with me?
Yes, yes.
I know some people are missing already. Let me bring in page 2 and work and do this. Let me get to this. Let me just copy this and bring it out to page 2. Okay. So can we see now that the H range, this is the H range. And this is, let me just turn this off. I'm not doing this thing today. I just want to avoid entering into something. Turn off the title. All right, so let me pull out the grid. I'm sorry everybody that I just got into this. Should have not general effect. I'm going to show us all of this. It's very can be very interesting. All right, so you can see now that we can see that total sales by H range. Total sales by H range. So we come here to title. Don't ask question. This is not the subject for today. Total sales amount by H range. So bolding it. We're gonna get to do this tomorrow. It's very easy. All right. Okay. So you can see that from here. You can see the H range. All right. Are we together?
Yes.
It's part of the things we're going to do tomorrow. So you can see, all right, you can see the total sales. You can see that we have 15,150 that came from the people within the age range of 31 to 40. You can see we have 9,250 that came from the people within the age range of 20 to 30. So we can see that we have only 3,650. So if you want to do targeted marketing, all right, if you want to do targeted marketing, the people that will be targeting will be people within the age range of 31 to 40, all right? I could even decide to come and bring in, what's the product's name? I could decide to bring in we're going to talk about this tomorrow, please. I'm sorry, product, then we can drag product name into region, into legend, can drag product name into legend, and you see what it will give us. It's too much. It's too plenty. Let me not put it. Let me see if I can bring category into it. Category is still plenty. It's still clumsy, so let me not keep put it. But look at this. So you can see this now. Okay. That the people within the age of 31 to 40 are the people that generated the highest number of revenue from our sales. Okay. The least revenue came from people of age 41 and above. So if you want to carry out targeted marketing, we want to go after these guys to sustain this level of patronage. And at the same time, we want to also go after these guys to see how we can improve their patronage. We see how we can, bring them up in terms of the number of volume of purchase. We can decide to find out which products are these people really going for, and we decide to market these products to them, all right, or give them some level of discount. Or we can also decide to find out what is responsible. Could it be the delivery time? There could all be a lot of factors that are responsible for the shortfall in terms of the number of people within this age range that patronize the environment. All right, so let's return back to where we were. So we're talking about DAX, all right? We're talking about DAX calculated measure and DAX calculated columns. Now, let me return back to where we started. I said that DAX column, that DAX is called data analytic expression. It's basically used to enrich our data sets or our data model for the purpose of analysis, all right? It enriches or it expands the scope of our data for the purpose of analysis, all right? So we can use DAX to create calculated columns. We can use DAX to create calculated measure. We also use DAX to create a table. An example is the calendar table that we've created. So I've also spoken about the context in which we should use calculated measure and calculated columns, right? Calculated columns is mostly used when we are working with dimension table. But when we are working with fact table, it is highly recommended that you use calculated measure in performing aggregate functions. Now remember that your analysis is basically using your dimension field to filter the result of your aggregate function on your fact table. All right? You want to perform average cells. You want to perform carry out average function on your cells, and you want to filter that across region. You want to see the average cells across region, the average cells across products. All right? For example, let's look at these average cells. Let's look at all of these that we've performed. All right? What if we go to bring a slicer? This is an example of a slicer. We bring in a slicer here. All right? And we bring in category into that slicer. All right, you can see that we have a slicer now, a drop-down slicer. All right, are we all together? Hello, are we all together?
Yes, yes.
Okay, so you want to slice all of this. You want to slice all of this by the category. You want to see what was the average cell. Do we have average cell here? Average cells amount across a time. What do you have? Can you see it was 1.5? What was the highest cell volume? It was 3. The total number of transactions was just 1. So it was just 1 transaction that was mapped to a time. All right. So if you filter this out, let's look at food. All right. You can see that we have the highest sales was 5. Sales volume was 5. Total transaction was 5. All right. And the highest sales value was 4,500. The lowest sale value was 500. The average sales amount is 1,660. All right. So you can see that these are aggregate functions that we have performed on our sales table, and we are now using a dimension. We are now using a column on a dimension field to analyze the aggregate functions that we have performed on our fact table. Are we together?
Yes,
Is
yes.
that clear? So analysis is basically performing aggregate function on your fact table or your numeric columns, and then using fields or columns from your dimension table to filter the outcome of that aggregate function. That's what analysis is all about. For example, you want to see the total sales by what? You want to see the total sales by products category. You want to see the total sales by what again? You want to see the total sales by product category. You want to see total sales by region. You want to see total sales by customer. All right. For example, let's say we wanted to see total sales by let's say you want to see total sales by product category. Let me squeeze this. You want to see total sales by product category. All right. So all you need to do is you can bring a table here and you bring your product category. All right. The next thing you want to do is to bring your total sales. All right. So you can see all the total sales mapped to product category. All right. Are we together? So you can see total sales by product category. Are we together?
Yes,
Hello, are we
yes,
together?
yeah.
So you can see that, you can see here that, I'm going to talk about this tomorrow. So you can see here that, food had the highest number of sales. The least came from airtime. Are we together? At a glance, you can see that. Are we
Yeah, which is
together?
okay.
Are you with me?
Yes, we are here.
Okay. So let me shut down here and we continue tomorrow. Any question?
Well, for me, maybe it's in tomorrow because I need to watch over this video again.
Everybody's quiet. It seems that I'm absent.
We need to go
Sir,
by it
today work
again.
is so complicated.
We need to go by it again so that we
We need
understand
to
better.
go check the
Yeah,
video.
we need to watch it over.
Yeah.
I'm unable to get anything today.
Are you serious?
Yes, sir.
I think it's a good place to call it a day so that we'll not come and mess up any small thing when person gets it.
Are you serious?
Yes, sir.
Chinwe, how about you?
It's so complicated.
It's
It's
like
the
we
easiest.
are entering inner Kakos.
This is the everything we were doing is coming to this. All right.
So visualization, okay?
Yes, now so we have already started entering analytics small. Do you
Small,
understand?
okay.
So analytics is where, remember I said that once we get into data modeling,
Yes.
within data modeling, we have DAX. All right. We are going to use
Yes.
DAX to enrich our data set or our data model.
Data model,
So when
yeah.
we enrich our data model, then we'll now start thinking like analysts. All right. So maybe by tomorrow, we'll look at this again and we'll look at business questions that we can derive from the data model and we use that to perform our analysis. But what you should go back with today is analysis is basically using your dimension, the columns on your dimension table to filter the result of aggregate functions you perform on your facts table. That is what analysis is all about. Did you get that?
Say it again.
Analysis is basically using the columns from your dimension table to filter the outcome of the aggregate functions that you perform on your facts table. That's all. Because on your fact table, the basic operation that you perform on your fact table are aggregate functions. Are you with me? Hello, are you with me?
Yes, sir.
Yes, we're
So
following.
when you perform that aggregate function on your facts table, what do you want to see again? You want to use the columns on your dimension table to filter it. For example, you want to see total sales by location. How do you achieve that? Total sales is on what? Fact table, sales table, right?
Yes.
You go to sales table and perform, you can perform an aggregate function of total sales, of total sum of sales amount will give you total sales, right?
Yes, sir.
When you finish that, what's the next thing you're going to do? You're going to go to your customer table to pick location to slice that total sales. So that total sales will be sliced by location value or location value in your location column. So you now see the different number of sales across the different location in your customer table. Are we together?
Yes, sir.
For example, category table. The category column is in your category, is in your product table, right?
Yes. Should we?
Now this is in your product table. Because category column is in your product table, while the sales amount is on your sales table. So what you did was to go and perform an aggregate function on the sales amount column on your facts table. Then you now use the category column from your product table to filter or to drill through the total sales amount. Now, I also want to show us why we are able to achieve this. We are able to achieve this because of this relationship that exists. We are able to achieve because of this relationship that exists. If this relationship did not exist, we won't achieve that. Look at this. Let me delete this relationship and see what will happen. I've deleted that relationship. Let's get back to our visual. What did you observe?
Oh, okay.
All of
okay.
them have the same value. We couldn't drill through. We couldn't drill down.
They couldn't read themselves. Yeah.
Do you understand? You couldn't drill down. You can see that it has the same value across. It couldn't split the value across each category. Are you with me? But when that relationship was there, we were able to split the value across the total amount across each category. Are we together? Hello, are we together?
Yes.
Is everybody with me? So if we go back to this thing now and drag product ID from here to product ID here, we drag product ID here and put on product ID here. There's a relationship now. If you go back to that visual, you'll see that it has splitted. Are we together?
Yeah, we're following.
I will talk about this tomorrow. I will try to bring it to a level where everybody will understand. So today is more like an introduction to it. So I will talk about this and I will bring in, I'm going to combine three things tomorrow. I'll return, you can see now that data modeling, DAX, and data visualization are related. Are we together?
Yes. Yes.
They are kind of related.
Related, yeah.
If you don't have if your model is not rightly defined, you cannot filter, you cannot have this. All right? You won't be able to drill through your analysis. It's going to affect your analysis. All right? So your model should be right for you to get the right visualization. So I'm sorry, we have to shut down here tonight. We'll continue again tomorrow.
Nice.
And by tomorrow, everybody will understand.
Thank you, sir.
Thank you,
All
sir.
right.
Thanks for the time. Thank you.
All right.
Thank you so much, Mr. Ekman.
Thank you, sir.
Yeah, you want to say something?
Thank you.
Oh, thank you to everybody. Thank
Good night,
you.
sir.
For,
Thank you.
Mr. Edson. Good night.
good night, everyone.
As well.